Hello and welcome back. In the last video, we covered Chapter 6 on 2D graphics. This next chapter, Chapter 7, is going to cover the basics of 3D graphics in Matlab. So here's our chapter outline, very short. We can basically do lines in Matlab and we can create surfaces in Matlab in 3D. So the objective is just to introduce you to some of Matlab's 3D plotting capabilities, again to include graphics management, curve, surface generation, annotation, and graphics. Here's just a summary again of those plotting functions and commands that we have available. We went over a little bit of the 2D last time, some of the more common ones that you might use. Today we're going to show just a few of the 3D options that we have available. So the 3D version of plot is plot 3. So in 2D it was just plot and then we had our input arguments. With 3D we use plot 3 and then we have all these different input arguments that we can specify here. So for example, UJ, VJ, and WJ, these three here, are just the X and Y coordinates of a point. So they can be scalars, vectors of the same length, matrices of the same order, or expressions that when evaluated result in one of those three quantities. CJ, this value, this input argument right here, is one character that specifies the color, one color that specifies the point characteristics, and then one or two characters that specify the line type. The set of 3D plotting functions available to create surfaces, contours, and variations of these basic forms, we can use this surface notation here. So the surface is defined by this expression. So X and Y are the X and Y coordinates in the XY plane, and Z is the resulting height. So we have two basic surface plotting functions. We have surf, XYZ, and mesh, XYZ. So X, Y, and Z are just the coordinates of the points of the surface. And then you can see here, surf draws a surface composed of color patches, where mesh draws white surface patches. The colors of the lines are determined by the magnitude of Z, so what was determined here. And let's see, I'm sorry, that's what's determined here. So, actually, time out, starting over. I totally just confused that. Magnitude of Z. Okay, starting over. I had it right the first time. I don't know why I tried to correct myself. All right. Hello and welcome back. Just kidding. This was supposed to be easy. Water. Okay. Hello and welcome back. In the last video that we recorded, we covered 2D graphics in Chapter 6. In Chapter 7, we're now going to be introducing the basics of 3D graphics in Matlab. Here's our chapter outline. Pretty short. We've got lines in 3D and then surfaces in 3D. So the objective is just to introduce you to some of Matlab's 3D plotting capabilities. That includes graphic management, curve and surface generation, annotation, and graphics. The book goes into a lot more detail than what we have here, but this PowerPoint just kind of highlights some of the more common functions that we might use here. So again, in 6.1 we showed this, we'll show it again here. These are just the basic functions and plotting commands that we have available. So here are some of the 3D plots that we have available. Here's some of the annotation and characteristics that we can use when creating 3D. We can also rotate in 3D, view in 3D, and then notice here these are 2D and 3D options that are available. So this is useful, for example, when you're labeling your axes and whatnot. Again, I'll show that in the example video. I'll demonstrate a lot of these for you. So lines in 3D, the 3D version of plot is plot 3, and then we have all these different input arguments here. So in 2D, it was just plot, and we had our input arguments. Now we have plot 3 in our input arguments. So we have UJ, VJ, and WJ. These first 3 arguments here are the X, Y, and Z coordinates, respectively, of a point. They can be scalars, vectors of the same length, matrices of the same order, or expressions that when you evaluate them result in one of those 3 quantities. CJ, this input argument right here, is a string of characters that specify the color, the point type, and the line type. Surface plotting in Matlab is also something that we can do. A set of 3D plotting functions is available to create surfaces, contours, and variations and specialization of these basic forms. So a surface is defined by this expression here, z equals f of x, y, where x and y are the coordinates in the xy plane and z is the resulting height or magnitude. So the basic surface plotting functions are surf xyz and mesh xyz. So the x, y, and z are just the coordinates of the points on the surface. So when we use surf, it's going to draw a surface composed of color patches. When we use mesh, it's going to draw white surface patches, which I'll show you an example of the difference between the two here in a second. The colors of the patches are determined by the magnitude of z when you're using surf. And for mesh, the color of the lines are determined by the magnitude of z. So here shows you your examples. If we use this surf function here, you can see here how this has resulted where the actual surface area is in color here. And again, the colors are determined by the magnitude of z. Then we have the mesh function where the patches themselves are white, but the lines are colored. And again, those the color of the lines are determined by the magnitude. So obviously, the higher you get here, it approaches from like an orange, yellow to a red, the higher that you go. And then you can see down here, this is really low, so these are in a bluish color. So this is an example that we're going to go through where we're going to take a surface created by this function here, and we're going to plot that using the surface command. So this is the syntax that we're going to use. Again, I'll just go over that in the next video when I show you how to use some of these functions in Matlab. If you have any questions, let me know. Otherwise, I'll see you guys next time. Thanks. Bye.